It's not. It's actually not. Because when we go our website, the weather's.
Okay, thank you guys for coming out this afternoon. We have Elliot Abrams here from AccuWeather. He's alumni department. He's got good stuff prepared for us, so I'll let him get started.
Well, you don't really know that I have any good stuff prepared. However, we'll see what happens. I wanted to show you an old type map that is used, where you actually look at a map that is in the metric system and come up with a rough idea of inches of snow. How many think that that's reasonable? How many think that's unreasonable? How many think that they don't know enough to answer the question? Good. Well, it could be reasonable or unreasonable. It's the 200 millibar analysis, and at 200 millibars, the upward and downward motion are opposites to the way they are below 500, so that in a trough it'll be warm, and in a ridge it'll be cold. And someone way before me, even though that may seem impossible, found out that you could actually take the difference in temperature between the warmest reading in the bottom of a trough, the coldest reading in the downstream ridge, subtract the two to get the difference, and then divide by 2, and that's a very rough estimate of the number of inches of snow you'll get. So I'm going to show you 2 test cases of this. One has already occurred, and this is from January 23rd, 0Z, so it's Friday night as the big blizzard was coming along. And we look here at the bottom of the trough in Alabama, and it's like minus 43 there. There's another minus 43 in that area. There's minus 40 here near New Orleans. So let's say it's minus 40. The downstream ridge has a minus 60. So that's 20 degrees spread. So you're looking at 10 inches there just from that crude thing. You don't really know what might be in between these spots, but you're dealing with a big storm from the night before. Now, of course, they had 2 to 3 times that much, but I would maintain that if you're stuck in a 10-inch snowstorm, you're probably also going to be stuck in a 20-inch snowstorm. You're trying to drive. But that's one idea. Now, here's today's situation, which has looked rather innocuous during the course of the week up to this point. But we notice that out here in southwest Missouri, there's a minus 43. And we notice here in Caribou, actually at Chatham, Massachusetts, minus 63. So there's a 20-degree spread across there. Now, there are some other things that go along with this so-called rule. You have to draw a line between these 2 points, and then you have to see where the low-pressure areas are at 850 and 700. You have to make sure that it's cold enough at the surface for it to snow. But the main thing is here, this just shows that there's probably good upward motion in the system below it. And so somewhere it's probably going to get a fair amount of snow. Now, general thinking has been that most of this falls back into the ocean, and the only people affected there would be people on ships or those marine animals that come up for air periodically, and they'll only have very temporary accumulation before they duck under once again. Their shark tank. So that's just a little thing. One other thing that this is helpful for is, let's say you think that a storm is going to produce a fair amount of snow, but maybe there's some of the ingredients are missing. One thing that all these storms need is a pretty good upward motion field. And so if you don't see a good spread between the warmth at the bottom of the trough and the downstream ridge, you're asking for trouble going for a lot of snow, because it may not happen. So it's both a tool to help you predict a larger storm and also to prevent yourself from going overboard by mongering too much for something that isn't really going to happen. So we're going to look mainly at this case today, where it is likely to snow. Forecast for here is fairly simple. I closed my eyes and asked myself, what is it likely to be like today? And I said, the clouds will take over. And of course, that's a great mystery here in central Pennsylvania that this occurs, that it could actually be a cloudy day at this time of year. Started out sunny, but then as soon as we get a little bit of convection, I guess we got some cumulus clouds that had spread out at the inversion level, and that was it for the sunshine. So, get rid of the 200 millibar. One other thing I like to look at on this site, this is the University of Wyoming site. I'm sure you have the same maps here, because anyone can get them anywhere. This is the 10 millibar chart. I'll just get a new one. For observations, 10 millibars, North Pole. Now this map can be helpful according to some research that's been done, and there was an article in Science around 2003, and I can get a reference if anyone is interested. But there have been other people who have looked at it before, that when typically there's a vortex at that altitude. And in the wintertime, sometimes you'll hear about sudden stratospheric warming. This isn't as much looking at the warming, but actually at the pattern of the height lines. And what will happen is the vortex will move quite a bit, or it can actually split or weaken and reverse to a high pressure area, depending on what's going on. But in this case today, you can see this, get map, and that's what it looks like today. Now the North Pole is somewhere in the middle here. Here's Greenland, and the North Pole is somewhere. This thing is suppressed in the northern part of North America, and is pushed over toward Asia. So there have been huge height rises and warming that's taking place over Alaska and northwest Canada in the past week. Now that we know that this has happened over the past week, we can look back at the previous map, say for January, say 26th. It's a previous map. And at that time, the vortex was squeezed a bit. It was closer to the pole, and certainly there was no ridge yet in North America. So what's the idea behind this? The idea is that there's some energy transfer going on in the troposphere that is then seen as an impact at the high levels of the stratosphere, and the energy, I'm sure, doesn't bounce down, because at 10 millibars, how much energy are you going to have to move the atmosphere at a lower level? But it's a signal that when you see this reversal take place, then maybe 10 to 14 days later, it turns colder. And so we'll see if this actually happens. We've seen this little bit of reversal now, and maybe 10 to 14 days from now it'll be colder. We can also look at the basic progs, and we know that it's going to be getting colder next week. We had this one little shot of cold air that came in yesterday and last night, but when the wind blows out of the west here all night, February 3rd, and it's only 40 degrees in the morning, you know you're not dealing with a really cold air mass. And many people thought that since the groundhog didn't see its shadow, that yesterday's spring-like weather was right around the corner just one day later, which was very impressive to me. When I visited the groundhog site, incidentally, 4 years ago, I found that from the stage, it's actually impossible to see the sun at sunrise, because there's a little hill in the way to the east-southeast of the site. So, and they also report the sighting of the shadow 3 or 4 minutes before local sunrise. So it's really a magical place, Punxsutawney. And I'm talking with some of I guess one of the most pithy comments I heard was from one of the fellows dressed in the garb. I see him at about 1 o'clock, and he says to me, "It's hard to keep this up all day." Also, another thing is Pothole Pete came out of the Fort Pitt Tunnel in Pittsburgh and saw his shadow and predicted 6 more weeks of front-end alignments. That's usually a good forecast at this time of year. Okay, so that's the upper atmosphere, and that's something looked at in the stratosphere. If you want to look this up, look at relationships between upper stratospheric changes and warming or cooling trends. And there have been some papers on this. And Joshua Cohen, I believe, who works at, I don't know where he works, but it's a place in Washington, and he writes a weekly blog about what's happening in the high stratosphere and the lows and the rest of the atmosphere on what he thinks that's going to do to the climate. He's pointing out at the beginning of the season that even though we had a strong El Nino, there was some evidence that maybe things were going to reverse and there'd be more cold air than some people expected. And I guess we've seen some of that, although it hasn't been extremely cold. So that's that part. Now for today, start this thing beginning. Wintry episodes in February of 2016. And there is a wintry episode. That's a farm I can see from the backyard of my house, and it's actually snowing during this time. And weather impacts travel. This is a picture of Washington's crossing New Jersey on a pretty, looking at New Jersey, Pennsylvania, a rather tranquil day. This obviously was not the time that George Washington crossed the Delaware. How do we know this? It's a bridge.
There were no cameras there.
There was no cameras there. That's right.
Picture.
And I have the picture. So this didn't happen then. And the amazing thing, of course, to historians and everyone is how was Washington? He was a brilliant person, but how did he know that the place to cross the Delaware would be at Washington's Crossing? It's just brilliant. Okay, but in the wintertime, there can be ice. If there had been this kind of ice in the Delaware at the time of Washington's Crossing in 1776, wouldn't have made it. Would have gotten stuck in the ice. Actually, that's what happened to some of its troops. They were just below the dam, below Trenton, and the tide came in and pushed all the ice up against the dam, and so they couldn't cross there. They were able to cross above the dam. And here, of course, another type of crossing. This is Amtrak's crossing at just south of Washington's Crossing. Now here's a video of the snarled traffic in Atlanta from 1 inch of snow. This is a 2-minute video. And you can see very clearly here what happened in this case. Started to snow, they got about a 1/2 inch of snow, and soon nothing moved. And you can see there's nothing moving here. This, of course, is just a photograph, not a video, but the video would have shown the same thing. The same thing happened in Washington the night before the blizzard began, which is an interesting forecast exercise. If you're a forecaster and you're trying to advise, say, snow removal departments what's going to happen, or the public how to prepare, and you have a giant storm that you're almost certain is coming, don't forget the little thing that can happen the day before, because that just tied up traffic terribly. You get an inch, half an inch of snow at 6 or 7 in the evening after it's been above freezing during the day. The first thing that happens is the ground freezes, water then freezes into ice, a little layer of ice, and then snow falls on top and hides it. And you don't need 10 inches of snow to do that. You can shut down a whole city just like that, as happened in Atlanta. And in the summer, we've got different hazards, and this is one with thunderstorms. And this is a time lapse of about an hour and a half, showing a day in which we had a thunderstorm, but also the flow started coming in from the east in the lower level of the atmosphere. We're looking here to the north-northwest, and the thunderstorms were coming from the southwest, and you can see the low clouds coming in from the northeast, and they're battling back and forth. At times the cool air gets deeper and then gets shallower. It's not really established, and it's just amazing to see the different motions here. This right to left motion is the low clouds with all the stratus in it, and every now and then you can see the higher clouds, which were from the warm, humid sector of air that was in place before. By the end of this video, the cool air has taken over, and you can't really see what's happening aloft. That's the situation we often have in the springtime with cold air damming. We'll be looking at the clouds overhead. It's impossible just with our eyes to see whether we're going to be getting rain or some thunderstorms or anything like that, and that's what, so radar is important. Years ago, before they had that, you're looking at the sky, it might rain, and who knew how long it was going to rain or how much there was rain there'd be. That's that picture. Okay, and then the next one is comes as a shock, I think. Now this is not lightning hitting the same place twice. This is when you take a video of one lightning strike and then reproduce it 15 or 20 or 25 times and make it look like a movie. So that's what happened there. This was on the Bald Eagle Ridge out to the northwest. And of course you don't want to be climbing mountains and climbing hills at the time when there are thunderstorms because of the danger of being struck by lightning. So we get summer thunderstorms. And then there are other cases in which clouds will build up at some point, and if you're not really paying attention, you can be caught by a thunderstorm. It doesn't have to be severe either. You've all been out riding a bike or running or something like that, and suddenly a thunderstorm comes along. Now, since you're all interested in the atmospheric sciences, you're never fooled by this kind of thing. But imagine if you're an average person among the public. How are they going to know? They may not have their TVs on to see if a warning is issued. How will people be warned if they're just listening to their iPhones or whatever and running, or they're doing some other activity? It's a problem with how do we get the warnings out to everybody so that they can be saved. In this case, the thunderstorm develops, and you see this scud behind it. What happens, there's a ridge behind our house, and it's a much longer downhill on that side of Bald Eagle Mountain than on this side. It doesn't look like much of a mountain from here. But the air comes up the slope, cooling takes place, the relative humidity is quite high to begin with at the bottom of the hill, comes up, air gets saturated, and these low clouds come racing up over the top, and it looks quite impressive, even though they're not really going to do anything. So that's that. And my message in all this is that the longer you dwell on the past, the shorter your time for making errors in forecasting the future. Does anyone agree with that idea?
You're not out of time.
It's a tough crowd. Well, anyway, that's that. Okay, so this morning's pressure analysis, this was at about 11 o'clock. This is at every 4/10 of a millibar, much tighter spacing than you get on typical charts that you might analyze by hand or see on a screen. You can see two things on this that are outstanding. One is a lot of details that you'd miss otherwise. For example, the spring, finding the exact location of backdoor fronts is done very well with this pressure analysis. Another thing you find is spurious information. Out here over the Atlantic, there's no data plotted there, and that should give you a suspicion that the data, the analysis there is probably flawed, and so this artifact here off the coast, this little ridge, is wrong. In any case, what we see is cold air damming on the west side of the Appalachians. Here we have a high pressure area to the west, and the cold, dense air is packed up against the mountains, and only some of it leaks across. And so that's why the ice bars are so close together right there, right at the mountains. And then you have a lee trough on the east side. What we're watching to see is there's a front sitting there with very warm, moist air in the southeastern part of the country. We have the cold air interacting, and we have a short wave coming in from the southwest across the Gulf of Mexico, getting ready to turn northeastward along this front. So how big a wave are we going to get on this? And the stakes are high because we know there's quite a bit of moisture with this system. It just came through yesterday. We had more than an inch of rain here. We know that the dew points are very high across Florida and southeast Georgia. So you tap into that moisture supply and it can snow 2-3 inches an hour. On the other hand, the storm is going to be limited. It will not last anywhere very long and will probably not extend too far to the northwest. So it's going to have a sharp edge to it. And places just out of the edge, they'll see the edge of the clouds. And you're growing up and wanting a snowstorm to come. It's probably the most frustrating thing you could ever see. You see the clouds from the storm coming along, and you hear the forecast of snow, and you feel the northeast wind blowing. It's 28 degrees, and then it clears. Isn't that a horrible thing? It's I think it's the second place to the snow turning to rain when you didn't want to. It's 33 degrees. So anyway, that's the pressure analysis. Here is the enhanced infrared picture from this morning, showing the area of clouds. What might we want to see in the southern part of this to indicate that a storm is forming? How many think that
the leaf structure in the clouds?
Leaf structure in the clouds. We might want to see this area of cloud, the western edge of it, bulging more. Now, if I put this in motion, I don't have a video of this. There is some sign of a little bulge actually in South Carolina and North Carolina at this point. But I suspect that that's not the event that all the models have for late tonight and tomorrow morning, because this flow is so strong that anything that's in the western Carolinas at high levels now is going to be gone long before that time. So we have to wait for something else to come in. There is a short wave that's coming in from the Midwest. I think that's this cluster of clouds you see out here in Iowa and eastern Minnesota, parts of Wisconsin. There have been some snow showers there. Very cold aloft with that, at 500 millibars. Some of the temperatures were minus 36, 37. That's one of the colder troughs we've seen in the U.S. this winter. And as this interacts with the system on the East Coast, there will be probably a bulge back late tonight. It looks like it doesn't really get its act together until it gets to southern New England. So our forecast this morning were that in places like eastern Massachusetts, Rhode Island, that since it's warm today, it's in the 50s, at first, as precipitation comes in tonight, it's going to be rain, but there will be a strong northerly flow at the surface, bringing in the cold air last minute. So toward daybreak, the rain begins to mix with some sleet and then change to snow. So it could be a very dangerous situation tomorrow morning. And think about the timing of this, how important it is for warning people about it. Let's say it rains till 9 o'clock and then changes to snow. Is rush hour affected? No. It rained. People got wet a little bit, but they all got to work or school. And if the storm then comes from 9 till, say, 1 or 2 in the afternoon, it doesn't really affect the work day because by the time people are going home, the roads have been plowed and schools can be let out. Now, some schools won't get the right information, and they'll see it snowing outside at 10 or 11 and call for early dismissal. And then they'll send the kids home in the worst part of the storm at noon, not realizing that the storm would be over at 3 o'clock and they could have waited. Those are the kinds of things that as a consultant you could tell them that isn't really in the typical forecast you hear. For example, you see a forecast on a website or a newspaper, there's one icon for the whole day. I mean, what's with that? I mean, how many days are the same all the way through? They're not. And if you listen to a detailed forecast, they'll be all different. There are different challenges in the various automated forecast systems that the National Weather Service struggles with and we struggle with trying to get the timing. There are all these millions of codes for specifying different types of weather, You have to get the right ones in to make the words come out right. The old days, people made forecasts individually for different places, and you had time to craft them so that they read the way you wanted them to. But the only way to make hundreds of thousands of forecasts for any place in the world is with an automated system. And that's a challenge to get the English language to bend to your codes to bend to what the weather's actually going to do. But anyway, so this storm would develop, and if it changes over to snow, say 4 or 5 in the morning, it can then come down several hours at an inch or two an hour in Providence and Boston, and they may wind up with something like 3 to 6 inches. Now, everybody's focus is on the accumulation, and the unfortunate thing about snow, of course, is since it's mostly air, our errors are very, very easy to see. And like in the head of the blizzard, people are asking me at the gym, how much snow are we going to get? And I said, well, I think we're going to get 2 to 10 inches. Of course, they laugh. And yet I was underdone on the range of snow in this area. You go past Bellefonte, there's virtually nothing. You go over to McAlevy's Ford on the other side of Tussey Mountain, where the state park is, 1.5 feet of snow. And you go farther south, of course, they have 25 or 30 inches. Which brings me to one other argument, measurement of snowfall. I think 50 years ago, the basic way was to take several measurements in a snowpack with a ruler or yardstick, and you took the average of those measurements, and that was how much snow fell. And today, there are standards of using a snowboard. The snow falls on the board, and then after a certain interval of time, what is the interval? 3 hours or 6? 6 hours. So at 6 hours, you measure the snow, and you sweep it off and start over again. So you get a series of 6-hour observations. However, in the real world, the snow is busily blowing along, some's getting compacted, some of the grains are settling into the snow cover. So in many storms, especially strong ones with strong winds, you'll never see the accumulation of snow that has been officially measured. So what do you put in the weather forecast? You forecast what people are going to see outside or what the snowboards are going to say. And it's a tough thing. I think we usually will try to go what the information from the snowboards is, because that's then what's generally reported as having been the snow fell. Then it's sometimes with some of the co-op observers, I'd say at least 90% of them try for an accurate measurement. Some, I think, just try to outdo their neighbors by a few inches and go with a little higher than some exaggeration. Anyway, that's enough of the snow. So New York City is a tough forecast for tomorrow morning because the storm may not be fully organized yet in time to give them snow. Maybe it just rains for a while, they get a few snow showers at the end, the city streets stay warm enough that it's just wet, and then it starts to clear. But if the storm's just a little bit closer to the coast, all of a sudden they're hit by several inches of snow first thing in the morning, and rush hour is completely messed up. And it's messed up to begin with, even if the weather's dry. So you get some snow and rain, and it's a real problem. And farther southwest, it's less likely to snow. So this storm then leaves, and then next system comes across from the west, doesn't really do that much. Looks like another storm develops in the Midwest during Monday, and we've seen all different kinds of solutions with additional waves. One earlier in the week was the storm was going to develop along the southeast coast, come right up the coast with heavy precipitation. And depending on which run you saw, if you were looking at the operational run, it might have come up to New Jersey. If you looked at an ensemble mean, it gave you something else. But if you looked at the different members, they were all over the place, maybe from Chicago to Cape Cod as a solution for where the storm was going. So anyway, in the work, you try to narrow these things down as time goes on and tell people, we don't really know what's going to happen next Tuesday and Wednesday. It seems like there will be a storm coming across the Great Lakes, and then a second center will develop somewhere along the coast, perhaps off New Jersey, and give a snowstorm to New England on Tuesday or Wednesday. But if it forms farther south, then more people get the snow. One thing that's virtually certain is that there's going to be an outbreak of lake effect snow with the coming cold next week, because only 5% of the Great Lakes are ice covered right now, which is very low for this time of year. And even when the lakes are snow covered, you still get some lake effect. Friction is less across that lake surface than, say, up the adjacent mountains, so you still get some differential friction, but there's not as much heat that is added to the system, and so the lake effect is weaker. But in this case, it may be much stronger. It's going to be a very cold air mass over several days. The good news, if you don't like cold, is that the longer range models are going for warmer weather in 2 weeks with a flow out of the west, which is directly the opposite of the signal shown at 10 millibars. So that's about the end of that. One of the confusing things to me with the high stratosphere argument is the papers I've read indicate that once this change occurs, there's a reversal in the high stratosphere, that often the pattern set up with cold will last for weeks or even months. And in a non-scientific way, that's kind of baffling to me, because how can a signal that comes and goes in say a few day period or a week or two predict something that is going to last 2 or 3 months, that none of the other things that happen afterwards are signals of some other change? And I think typically with this kind of question, there isn't really enough of a question that's worth answering that you get a grant for it if you're a grad student or a professor. And so nobody does the research on this. Similar issue is the whether or not there's an enhanced precipitation immediately after the full and new moon. I got a paper out of the trash here when I was a freshman, and a person named Glenn Breyer, who developed a skill score for forecasting, had written a paper where he believed he had found a correlation between enhanced heavy precipitation events and the lunar cycle, where 3 to 5 days after the full new moon, he found a statistical relationship showing that the precipitation tended to be heavier during those times. But nobody's really followed up too much on it. There was a paper I saw came out the other day showing that some relationship between the lunar cycles, and I didn't really understand what they were talking about, but they said there maybe a 1% relationship. So, any questions on this pattern? The key in all these forecast challenges we had, they're very interesting to watch. We use all the different models, is how can we make the best forecast to help people in their daily activities, and how can we find out what various industries need for information. For example, a trucking company. Let's say that you knew exactly how long it takes to go from one terminal to another on a dry day. What happens on a wet day? What happens on a snowy day? If you can work out those relationships and then plug in a forecast for that customer, they know how they can rearrange their strategies and logistics so that they can shift loads or shift trips so that they can take advantage of whatever weather is going to occur. Same thing with stores. A number of stores can stock up on winter type things like shovels and plows, and if they can do it far enough in advance, then they're ready for the next snowstorm. But if the snow turns to rain in the stores that are well stocked, there's going to be a lot of angry people at the chain of stores after you've given them that forecast. But it's all very fascinating.
I have a quick question on your snow measurements. What is the average error? Have they done a study between snowboards and just what was done in the past? I'm sure there's a reason why they switched over to snowboards. For standardization, but I can't imagine the error being more than an inch. I mean, on large snowfalls.
Does anybody know?
I'm curious. Does anyone know?
I haven't really studied it, other than that I think it's less at the total.
Okay.
Has anybody seen any figures for, has anybody even fussed over it?
I fussed over measuring snow.
Oh, yeah.
Yeah, I was just kind of curious if there was some kind of, it was profound.
I get your drift. I mean, if somebody alleges that a certain measurement will give the wrong answer, they should also be able to back it up and say, well, does it this percentage at various accumulations? I suspect that at the highest end of accumulations, the error is greater than on a small snowstorm. And so if you're talking about record snowfall, the previous record had been, say, 25 inches at a certain place, and now it's 25.5 in some new storm, how much of it is because there was an extra half inch and how much of it is because of measurement error? I don't know, but that's an excellent question, and somebody found that out. You could probably keep a statistical sample of these, measure different snowstorms, and then see how the snowboard method works, and then compare the two. and test the hypothesis there's a difference or not.
But with that, New York missed their record for all time by 1/10 of an inch, which, how do you know exactly with the snowboard that was 1/10 off?
Those are the great mysteries. But it goes to politics too, because people will look at this information and some people will say, aha, that proves climate change. Others will say that politicians are the ones that are behind the idea of climate change. I think it's total nonsense, but they'll say that. People say what they want. You see the different candidates doing that. And so how do you combat that with actual science? Will people actually listen to actual science? It's a challenge. Any other comments, observations, or thoughts?
All right, well, thank you very much, Elliot.
Have the best afternoon that you've ever had till tomorrow.
Next week's
One thing I wanted to add, has everybody heard the barometer story? Do I have a moment to tell the barometer story? There's a meteorology class, and the students are told that they could measure the height of a building using a barometer, that you get into the floor, into the elevator, and at each floor you measure the pressure, then using the hydrostatic equation, measure the height of the building. So on the test, the professor asked, how do you measure the height of a building with a barometer? And one student said, well, I'll go up to the top of the building with a stopwatch. I'll lean over the edge of the roof, drop the stopwatch, drop the barometer, and start the stopwatch. And when I see it hit the base, the floor, the pavement, stop the stopwatch, count the number of seconds, and use the gravitation relation to say what the height of the building was. And the student was failed. And the student appealed to the head, went all the way to the head of the department, maybe to the dean. And the dean said to the teacher, maybe you need to let this person answer it again, because I mean this might be the right answer, using a barometer to measure the height of the building. And she says, well, I guess they're upset because I went to the roof and it says authorized personnel only and I'm not authorized. But let me try another way. When you go up to the top of the building, and on this barometer there's usually a little hook on it, so I'm going to tie a string to the barometer. I broke the apparatus the first time. That could have been the problem. And so I will lower the barometer down from the top of the roof to the bottom and see how much string I played out, and that will tell me the height of the building. And again, the student was failed, and again appealed once more. And as I guess you're really upset that I went outside to do this, or that I almost could have lost the barometer, but I know that inside, I know how long the barometer is. I can go end over end down the stairwell and add up the number of times I did that, and I'll get the height of the building that way. And again, it's failed. They said, this is getting frustrating. Why don't you know the answer to this? And she said, well, there's another way to do this. I know it's almost Christmas time, and I know the custodian has the blueprints of the building. So what I'm going to do is I'll go to the custodian and say, Madam Custodian, I have this barometer that I'd like to give you as a gift if you will let me see the blueprints for this building. The trade was made, and the blueprint was used, and she knew the height of the building. And again, was failed. And everybody was getting very upset. Why didn't you just do the way this was done in class? And she said, well, I could have done that. And she goes up to the blackboard and actually does it the way it was taught in class with a hydrostatic equation. Why didn't you do that the first time? And she said, well, at the beginning of the class, you told us that we should all be creative and think outside the box, but every time I tried, you failed me. So that's the barometer story. Anyway.
All right, thank you. Next week will be Paul Knight.